described with potentially different functions. First one is the bilateral distributed network, shown here in the orange. So it involves the areas on the both left and the right temporal cortices and also the inferior frontal areas. And this network is being described as involved in more general linguistic processing, lexical information access, sound-to-meaning mapping, and non-linguistic complexity. The left lateralized language network, comprising of the left temporal areas and the left inferior frontal areas, has been described as a network for processing complex linguistic stimuli, or the complexity which is relevant for sort of linguistic demands, and also for processing of complex sentences. So this is the network that we're trying to understand what it does. The organization and the function of this network has been debated. And we know this is activated by both inflections and phrasal syntax. These are functionally quite similar devices, especially in Russian, as I would later show, well, probably you already know. They both, so here's an example of inflection, plays. So S informs us something about the structure of the sentence. It tells us something about the subject. So the subject is the third person, singular. And phrasal syntax, phrase like I play, will tell us about the structure explicitly by having the pronoun and the verb. So however, the way that this is conveyed is quite different. For inflections, the S, the morpheme, is much closer integrated to the stem and potentially requires more phonological passing to access the meaning. Whilst in phrasal syntax, the I they are morphologically more or less independent. So there's two components, and hence the meaning is inferred from the combination of the both, but in a quite different way that is done in inflections. Inflected words produce a distinct left front temporal activation, and they produce activation quite different from the words that do not have inflections or have embedded stems. And this activation has been associated with the morphological passing, the stripping of the suffix and the stem. Also potentially relevant for the access of the grammatical information, which is associated with the meaning of the suffix. This same network has been shown to be relevant for grammatical processing or relational processing in sentences. More complex sentences generally generate greater activity in this network on the left. And in this particular model proposed by Federici, we have dissociation between two types of structures: hierarchical structure in syntax and linear structures. So hierarchical structures are the structures that contain some embedded dependencies. So example in English would be, the man who is walking his dog in the park is my friend, for example. Whilst this type of structures has been related to the dorsal stream, comprising of BA44 and posterior STG. Whilst the simpler linear structures, represented by the combinations like this girl is Mary, are considered to be simple and related to the linear structure and processing in the ventral stream, BA45 and anterior STG. So our first question was, to what extent does the left front temporal network and the activation of which reflects the morphological passing effects or the grammatical information processing? For this, we compared Russian inflections and phrasal syntax. As you know, that Russian inflections are quite complex and relay a lot of grammatical information about the sentence structure. And they can be embedded in complex hierarchical syntactic structures. And they're similar to syntax, they relate similar information. So читающие, те, кто читают, can be used more or less interchangeably and carry quite similar grammatical information. However, the way that this grammatical information is accessed is quite different. In читающие, you have to strip the morphemes from the stem and then access their meaning. So we hypothesized that perhaps if the left fronto-temporal activation is related to this process of morphological parsing, we would see the greater effects for the inflection condition. And our second question was, is the effect of the linear versus hierarchical structure? So for this, we compared what we just described, complex, what we'll call hierarchical stimuli, inflections and phrases, with the simple ones, to read well, that are not used or do not give any information about the complex syntactic structure that they can be embedded in. So, and we asked if both inflections and phrases would produce, the hierarchical inflections and phrases would produce a great activation in this network. So this is the experimental design table. So the two questions that we asked represented by the contrast, inflection versus syntax. This is the question about morphological parsing. And the second about relational processing, simple versus complex. Also we include derivations. The derivations have been shown not to activate the left-arm pattern system to the same degree as the inflections do, and is arguably because they contain no relational or grammatical information and potentially are stored as full forms. And we wanted to check that if this is true in Russian. Our experimental method is quite standard. We used Russian native speakers. We also used the acoustic baseline, which was abstracted from every condition. Our acoustic baseline was the musical rain. I'm not sure if you've ever heard anything like that. I will try to play it if that works. Let's have a look. Yeah, so this acoustic baseline is matched to speech in acoustic complexity. We also use it as a length control because, of course, our inflections are much shorter than the phrases. We used standard preprocessing and univariate analysis in SPM, but also, I'll present it later, we used RSA analysis, so representational similarity. I'll talk about it later, and standard thresholds. So this is the results of our first question. We hypothesized, remember, that the inflections, although similar to phrases in their grammatic complexity, because morphologically more demanding, will produce greater effect in the left fronto-temporal system. But we see no such effect. In fact, they both activate the same amount of the system. Although they look a bit different, but if you actually statistically compare them, subtract one from the other, there is no effect. Hence, we'd have to say that it is not as sensitive to morphological parsing, the network we hypothesized would be, is not as sensitive to morphological parsing properties of our stimuli. Here's the contrast, the same compared with the derived words. Derived words produce distinct bilateral temporal activations. And this is consistent with the previous results that obtained from English and Polish, and potentially this is because they do not carry as much grammatical information. This is the results from our second question. So simple minus complex contrast. As we see for syntactic conditions, so simple syntax, remember, хорошо читать, with the complex syntax, те, кто читают, absolutely the same, no difference when you subtract one from the other. For inflection, this picture is quite misleading because it looks as if the inflection, the simple inflection, produces less activation in the LIFG. However, when you statistically compare them, this is the results what we get. In fact, the greatest difference between the two is in the bilateral temporal network. When we asked what is the general kind of difference between the conditions in the ANOVA, in the analysis of variance, we see that this network seems to be sensitive to the what we call grammatical conditions, to simple syntax, and complex inflections. So they are simple syntax хорошо читать, complex syntax те, кто читают, complex inflection читающие. So conditions that carry grammatical information seem to cluster together, but not where we expect them to. So there's the summary here. Grammatically informative inflections and syntax, they do result in greater fronto-temporal left areas, and we presume this is because they both syntax and inflection access grammatical information in a comparable way. But we see no effects if the increased morphophonological passing demand or the difference between the hierarchical versus linear structures. Instead, what we see is the clustering of grammatically informative or relational processing informative conditions together in STG bilaterally. So the second bit is shorter than the first one, and also something we're working on as a work in progress, is the representational similarity analysis, searchlight, that we used to ask the same questions, but different method, to a different statistical method, which is quite which has different assumptions from the univariate analysis. So I'm going to take you through the steps of it conceptually, and if you have questions, you can ask later as well. So first of all, if you remember that univariate analysis shows us the intensity, the bold activation intensity across large areas, and we can subtract one condition from the other, and we ask the question where the activation is more for one condition to the other. In RSA, this is not what we are looking at. In the RSA, we are looking at the information level, we're looking at the fine-grained voxel activation pattern. And what we do is that the spatiotemporal searchlight, like if you want a patch of cortex, moves from different parts of the cortex, centering on each voxel in turn, and extracts the activation patterns associated with each condition, and then compares them. So, and this information is stored in the matrix. So this matrix, for example, here, shows us how similar, or how dissimilar to 1 minus correlation, are the conditions for this particular patch of cortex in these two conditions. So we see the diagonal is blue, all conditions are similar to each other, or well, they have to be. And this patch, the yellow patch, the little cell in the matrix, shows for this particular searchlight in these two areas, for these two conditions, how the fine-grained, unsmoothed activation pattern is different. And the next step, we compare our data with our model. Now, our model is a matrix, representational similarity matrix, that shows our hypothesized, our hypothesis about how we think the conditions are similar or dissimilar based on their experimental properties. So in this particular model, we would say, okay, so we would like to see where in the brain all inflections, so CI stands for complex inflection. So that you see this matrix is identical. So the blue represents similarity, red is similarity. So where all the inflections, the activation pattern for inflections is the same, and all other conditions are different. So this is the brief overview of this analysis, and to repeat, it allows us to access information carried by the voxel level activation patterns, and this is complementary to the univariate analysis, but shows again that we have to keep in mind the assumptions what it shows to us. So this is some models that we tested. We tested the model I just explained, where all the inflections are similar to each other. And surprisingly, to the univariate results, there is no such place. I do remember the simple inflections were quite different to the complex inflection in terms of the activation patterns in the univariate. However, if we asked where all phrases, so that's more than one word, хорошо читать, те, кто читают, are similar to each other, while everything else is dissimilar, we find the bilateral temporal with more left activation. The next model I think is quite neat. It looks at the relational processing. So remember, Anna showed us that our inflections, complex inflections, so читающие, simple syntax, хорошо читать, and complex syntax, те, кто читают, behaved quite similarly. And it listed more activation in the bilateral temporal. And this is the model that we tested here with the RSA. And yes, we find the same areas, but what it tells us is that the conditions that carry grammatical information are not simply create greater activation in bilateral temporal, but they create activation of a similar fine-grained voxel level activity patterns. So this is some conclusions, and I'm sure you can attempt to debate them. Grammatically more informative conditions, inflection, phrases, syntax do activate the same amount of left frontotemporal, the same amount of the left frontotemporal cortex, in a comparable way. Therefore, we can say that the rational information in both inflections and syntax is accessed in a comparable way. But derivations don't. However, the network, which we hypothesized would be quite sensitive to these properties, is not. There is no effect of increased morphophonological passing or a hierarchical versus linear syntactic structure processing. However, what we do see is the bilateral temporal network showing similar activation profiles for conditions that provide more relational information. I'd like to thank my collaborators, William, Marslen-Wilson and Mirjana Bozic, and I'm very happy to take any questions that you have.
Questions, please. Yuri.
There are sparkles in this room. Thanks a lot, Anastasia. Very interesting data. Very convincing.
Very strange.
Strange, but convincing in its way.
Strange and
how do you, speaking of RSA analysis, how do you come up with these models? And isn't this a oversimplification just to have? Isn't this an oversimplification to assume this sort of binary, everything's similar and a few bits dissimilar, or just?
Absolutely, yes.
And how do you choose, and how many models do you come up with? And once you start checking all of them, do you then run into multiple comparison?
Yeah, of course, we try not to check too many models, but the RSA analysis deals with the multiple comparisons to a certain degree. The models, the question, how do you come up with the models? They're hopefully based on your experimental hypothesis. But I agree that the binary models are very simplistic and do not represent particularly fine-grained properties of the stimuli that we are talking about. So this is very, very preliminary results, and they're based on our univariate analysis, the groupings of the models. But yes, we tested a few non-binary models. For example, the model that represented the, I think we ran the frequency model, how frequent are different, the lemma frequency model, and that showed nothing. But I think the problem with this data is that the matrices that we have, you think it's 6 by 6, right? Yeah? So we didn't do an item level analysis. So it would be quite hard to find a match. The function that you want to be testing would have to be quite robust, right? And if lemma frequency doesn't show up, what do you expect to show in a 6 by 6 matrix?
More questions? Comments?
Oh dear.
Thanks for the interesting talk. I was wondering, could you tell me a bit more about the derivations you used? Because I don't know any Russian, and I was wondering, like, what type of derivations you used. Are they transparent or opaque?
Okay, so...
And the exact difference between the simple and the complex?
Yeah.
I don't really get that.
Yeah. So for the derivation conditions, we had simple and complex derivations, right? Prikaz is a simple D-verbal noun. Sorry. And presumably it's either has a zero derivation, so it backed form prikazywać minus at prikaz, or it doesn't. And the complex forms, перевозчик, they would have at least two suffixes. Yeah, so either would be a prefix and a suffix, or two suffixes. And here's example of deliveryman. So peri is a cross, voz is the stem, and shik is the suffix that marks profession, like English, like teach her, archer. So they have meaningful parts in it, so they're morphologically complex, and maybe we do decompose them to a certain degree, and this is what we also wanted to see if that will show up. But apparently not.
And they're transparent. They are transparent?
Yes. Yes.
I have a question based on this slide. When you call your infinitives simple forms, I'm thinking about a citation form rather than a simple form, because something that I have not reported today were our control conditions where we matched nouns with the verbs, and those verbs were infinitives, something like читать кровать. And we didn't see any processing costs for infinitives in native speakers either. So to me, those infinitives are not very good examples of a testing material for morphological structure at all. My 2 cents. What do you think?
Yeah, but they weren't, they were not specifically targeted to test the morphological contrast. We had the complex inflection versus syntax, where one is clearly much more morphologically complex. Читающие, 3, if not, people argue 4, different suffixes.
Right.
I absolutely agree that that's what we see, they're not processed in the same way, but I think the reason for that is because they don't carry, not necessarily because they the affix can be still stripped and accessed, but the fact that this affix does not carry any grammatical meaning, what does it tell you about the structure that it's used in? Very little, I guess. It doesn't tell you, yeah. So I agree that they are not good examples of morphologically simple, but they are simple in terms of their structure.
Right.
That's what I was trying to refer to, yeah.
Right. Thank you. More questions, more comments. We have a couple more minutes, and we can use them to move on, but...
Just a brief clarification. Presumably all the subjects were bilinguals. Were they English speakers as well?
Yes. You can't, people who come to, Russian people who come to Cambridge, they normally speak English. But the thing is, I tried as hard as I can to make sure that they didn't live in the country for more than a few years, or were students, like exchange students. They did speak English relatively fluently. None of them were born and raised in the country. But, yeah, you can't help. Thank you.
Thank you very much.